Picture this. You're late for a flight, sprinting through an airport, and every departure gate has been rearranged at random. Nightmare, right? Now imagine the same airport with crystal clear signs, moving walkways, and a perfectly ordered gate map. Suddenly you glide to your plane with time to spare. That effortless journey is exactly what the right data structure does for software. Before we get technical, let's distill the core idea. A data structure is a deliberate strategy for how information is laid out in memory so the computer can find it, add to it, or reshape it fast. Operations like search, insert, and delete are the daily commute for your CPU, and the structure you choose decides whether that commute is gridlock or open highway. Think of a weather app refreshing your hourly forecast. Behind the scenes, temperatures arrive as a stream of numbers. Store them in the wrong structure and your app freezes like a polar vortex. Store them well and the forecast feels instant, even on a budget phone. Let's break down the classics, add a splash of real-world flavor, and sprinkle in performance secrets. Array. Imagine a row of numbered lockers. If you know the locker number, you grab the contents in a single motion, constant time access. The trade-off, lockers come in a fixed line. You can't squeeze a new one in the middle without shoving everything over, which is costly. Arrays power image buffers, audio waveforms, and any place you need lightning-fast indexing. Linked list. Picture a scavenger hunt where each clue tells you where to find the next. You can insert a new clue anywhere just by adjusting two arrows, so inserts and deletes are cheap. But to reach item 100, you must follow 100 little arrows. No shortcuts. Linked lists show up in music player playlists, browser history, and the unfurling comment threads of social apps. Stack. Visualize a stack of dinner plates in a cafeteria. Last plate on, first plate off. The fancy term is LIFO, last in, first out. Stacks are perfect for an undo button, recursive function calls, and even the back button in your browser. Performance is dreamy. Push or pop takes constant time. Queue. Now swap the cafeteria for an airport taxi line. First in, first out. A queue keeps things fair. The earliest request is served first. Print spools, task schedulers, and multiplayer game lobbies all rely on queues. In queue and dequeue are constant time, making queues the unsung heroes of smooth user experiences. Hash table. Think of a library's index card catalog that jumps you straight to the shelf location of any book. A hash table turns a key, like username, into an address in an instant. Average lookup is near constant time, even in millions of records. Your phone contacts, database caches, and most login systems lean on hashing to feel instantaneous. Tree. Flip open your laptop's file explorer. Folders within folders within folders. That's a tree. In a balanced tree, search, insert, and delete all happen in logarithmic time. Every extra level doubles capacity, but adds only one extra step. Trees power everything from autocomplete suggestions to the entire document object model living inside your web browser. Graph. Imagine Google Maps. Cities are nodes, roads are edges, and suddenly you have a graph. Graphs capture relationships, friendships on social media, flight routes, even neural networks. Algorithms like Dijkstra's or A-star weave through graphs to uncover shortest paths or strongest connections, often in milliseconds. So, how do you pick the right tool without a crystal ball? Ask yourself 4 questions. 1. Do I care more about fast lookups or fast insertions? Arrays and hash tables excel at lookups. Linked lists and trees excel at insertions. 2. Is the dataset fixed in size or does it grow like weeds? Fixed data plays nicely with arrays. Unpredictable growth favors linked lists or dynamic trees. 3. Do I have relationships more like a ladder or a spider web? Hierarchical ladders love trees. Messy spider webs demand graphs. 4. What's my big O budget? If you can't afford ON scans in production, rule out structures with slow lookups under load. A seasoned developer mentally runs through these questions the way a chef chooses knives, automatically, instinctively, and always for efficiency. Let's land the plane. Data structures are not mythical beasts. They're disciplined ways to tame information chaos, turning raw bits into responsive features your users love. Master them, and you'll write code that feels magical, snappy, lean, and ready for millions of users. If this deep dive sparked an aha moment, hit like, smash subscribe, and ring the bell. Until then, keep coding, keep optimizing, and may your arrays stay in bounds.